Today, let's look at graphing quadratic equations in standard form of the form y equals ax squared plus bx plus c. The graph of the quadratic equations are U-shaped and are called parabolas. We'll start by creating a table, and I'm going to pick values -2, -1, 0, 1, and 2. This is just a random set of values that's going to give us the general shape for the parabola. So we'll plug in a -2 into the equation, and -2 squared gives us a +4. We'll plug in a -1 for x, and when we square that we get a +1. We'll substitute a 0, 0 squared is 0. And so you can see here we have 0 squared is 0, 1 squared is 1, and of course 2 squared is going to give you 4. Now we created a table so we can graph the parent graph for the parabola. This is the parent graph for the parabola because this is the simplest parabola you can actually graph. It's known as the parent graph of the parabola. So we'll plot the points -2, 4 first. And then according to our table we have another point, -1, 1, 0, 0, 1, 1, and the last point here is 2, 4. Now we just picked these 5 points, but we could have picked more. This parabola does not stop here. It extends forever on the right, and it also extends forever on the left. We just picked 5 random points that shows us this general U shape for this parabola. Now let's discuss the domain of the parabola. That's how far this graph extends to the left and how far it extends to the right. It goes to the left forever and it goes to the right forever. For the range, it goes down to 0. That's the lowest y value we can have, and it goes up forever. So the range of our graph is all the way down to 0, including 0. That's why this is a square bracket, up to infinity. Now let's look at the strategy for graphing quadratic equations in standard form. The first step is to find the vertex. You're going to use this formula, x equals -b divided by 2a. After you use this formula, you'll plug it back into the equation, the original equation, to solve for the y coordinate. And that's the first step, to find that vertex. It should be in the form x, y, because it's a point on the graph. Let's go back to our original graph. The vertex is right here. It's the point at which the graph starts changing directions. This is known as the vertex of the parabola. The next step is to find the y-intercept. To do this, you will let x be equal to 0 and then solve for the y-intercept. To solve for the x-intercepts, you will substitute 0 for y and then solve for it either by factoring or using the quadratic formula. The last step is to use the axis of symmetry to add additional points to the graph. All parabolas are symmetrical. They will be symmetrical about the vertical line that runs through the vertex. So let's draw a standard parabola here. We're going to have an axis of symmetry that runs down the middle of our parabola, and this point is symmetric across the opposite side. So the distance from this to the center is the same distance on the other side. So this is a symmetric parabola. Let's look at the first graph. Step 1 is to find the vertex. We'll use the formula x equals -b divided by 2a. And for our problem, this is b, and the a is equal to 1. So we'll have x equals negative 6 divided by 2 times a positive 1. X is equal to negative 3. This is our first coordinate for our vertex. Our vertex is going to look like 3 comma something, and that's what we're going to find next, the y coordinate. To find the y coordinate, we substitute negative 3 into our parabola. So y equals negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is 9. 6 times negative 3, that's negative 18. 9 minus 18 plus 8, altogether that's negative 1. So the x coordinate is negative 3. So I made a mistake here. We're supposed to write here negative 3 for the x coordinate, and the y coordinate is negative 1. So let's write that there. So that's our vertex. That's the first thing we need to graph. Negative 3 comma negative 1. That's our very first point. The second mission that we need to do is to find the y-intercept. To find the y-intercept, you let x be equal to 0 in the original equation. So we'll substitute a 0 for x in the original equation. So y equals, let's do the substitution now. This is 0 squared plus 6 times 0 plus 8. That's 0 squared plus 6 times 0 plus 8. So you get y is equal to 8. So the y-intercept is the point 0, 8. So we'll graph that onto our Cartesian plane here, 0, 8. And now we'll find the x-intercept. Let's find the x-intercept. To find the x-intercept, you're going to let y be equal to 0. So in the original equation, we have 0 equals x squared plus 6x plus 8. I can factor this. This factors as x plus 2 times the quantity x plus 4. And so if you solve this for x, you'll have x equals negative 2 or x equals negative 4. And that means we have two x-intercepts. The point negative 2 comma 0, that's one. And the other one is negative 4 comma 0. Again, y was equal to 0 and we had found two x-intercepts. So we'll graph that on the graph now. Negative 2 comma 0 and a negative 4 comma 0. This is negative 2 comma 0. And this is negative 4 comma 0. We could draw a vertical line that runs through the vertex, and this is our axis of symmetry. Using the axis of symmetry, I can find a third point right here. This is equidistant on the other side, so this must be another point on the graph. And now we can draw our parabola. We're trying to make a smooth curve that resembles a U-shaped object. So there you go. This is our parabola. So the first step is, of course, to find the vertex. We let x equal negative b over 2a. Use that to solve for the x coordinate. After that, you'll plug that into the original equation to solve for the y coordinate, and that gives us the vertex. Step 2 is to find the y-intercept. You'll have to start by letting x be equal to 0. Plug that into the original equation, solve for y, and that gives us that y-intercept. The next step is to find the x-intercept. To do that, you let y be equal to 0, and so in this case we were able to factor, and we had two different x-intercepts. plot all those points, and then you can draw your parabola. Try to make it a smooth U-shaped object. Let's find the vertex first. We're going to let x be equal to negative b over 2a. This is the formula we need to find the vertex. So in our case, we have b is negative 4, so this is a double negative 4 on top, 2 times, and we have a of 1 again. So this is equal to negative 4 divided by 2, or a positive 2. This is our x coordinate for the vertex. So the vertex looks like 2 comma something, and we'll solve for the y coordinate. We'll need to replace the x's here with the number 2, and so we're just going to do substitution to solve for the y coordinate. Y equals 2 squared, which is 4. Negative 4 times 2 is negative 8, plus 4. So in this case, we get y is equal to 0, which means the vertex is the point 2 comma 0. That's our vertex, 2 comma 0. Let's plot the point, 2 comma 0. And now the next step is to find the x-intercept. To find the x-intercept, we set the original equation. We're going to let that y be equal to 0. So we have 0 equals x squared minus 4x plus 4 is equal to 0. And if you factor this, you'll get x minus 2 times x minus 2, which means x is equal to 2, or x equals 2. But that's actually the same point. That represents the point 2 comma 0, which is already the vertex. So the vertex is also the x-intercept, because this point here is also an x-intercept as well as a vertex. Now we'll find the y-intercept. We'll let x be equal to 0, and so we have y equals 0 squared minus 4 times 0 plus 4. Again, we're substituting the x equals 0 into the original equation. So that's y equals, we have 0 minus 4 times 0, that's going to be 0, plus 4. So this simplifies to 4. That means the y-intercept is the point 0 comma 4. Let's plot that on to the graph, 0 comma 4. That's located right here. Now I could draw my axis of symmetry down the middle of the vertex, and then we'll look at a point that's equidistant on the other side. So this 0 comma 4 is used, and then we could sketch a rough shape parabola. It's a good idea to purchase some graph paper so you can do these parabolas. Let's look at question 3 now. We'll start with finding the vertex. To find the vertex, we let x be equal to negative b divided by 2a. This is the formula that we need. The b is equal to negative 4, and the a is equal to a positive 1. So we have x equals negative 4 divided by 2 times 1. And if you simplify that, that's actually a positive 2. So the vertex looks like the point 2 comma, and we'll have to solve for the y coordinate. To solve for the y coordinate, we're substituting the 2 into the original equation. So it's 2 squared times negative 4 times 2 minus 7. This gives me 4 minus 8 minus 7. And so y equals a negative 11. That means our vertex is off the charts. It's 2, negative 11 at this point right here. This is the vertex, 2, negative 11. Next step is to find the x-intercept, and to do that we'll let the y be equal to 0. To find the x-intercept, you're going to let y be equal to 0. So we have 0 equals x squared minus 4x minus 7. Now always try to factor. In this case we can't factor it, so we're going to either use the quadratic formula or completing the square. It's up to us. I'm going to just use the quadratic formula. A equals 1, B equals negative 4, and we have C here equals negative 7. Here's the formula for the quadratic equation. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's simplify this by doing substitution. We have negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is negative 7. And we're going to divide that by 2 times 1. And if you simplify the inside here, we have x equals negative 4, which is a positive 4, plus or minus the square root of, we have negative 4 squared, which is 16. Negative 4 times 1 times negative 7 is a positive 28. Divide that by 2. So we have x equals 4 plus or minus the square root. We have 16 plus 28, that's 44 over 2. You can simplify that a bit. This is 4 plus or minus 2 root 11 over 2, which actually simplifies a little bit further. This simplifies to a 2 plus or minus root 11. Now this is a ugly x-intercept. We have two x-intercepts. It's going to be the point 2 minus root 11 comma 0, that's 1. And the other one is 2 plus root 11 comma 0. So we have two ugly x-intercepts. But I can plug these into a calculator and we can simplify this. Let's use our calculator here. I'm going to go to desmos.com/scientific, and then we'll enter into the calculator 2 plus the square root of 11, and that gives us about 5.3. We could edit this and do 2 minus the square root of 11, which gives us negative 1.3. So we have two approximate values. The first one for the plus is 5.3 comma 0, and the other one we have negative 1.3 comma 0. And we did that using our Desmos calculator. Again, that's desmos.com/scientific. So we can approximate these points, negative 1.3 comma 0 and 5.3 comma 0. We don't have to be perfect. We'll just estimate. Let's say that's negative 1.3 comma 0, and we'll have 5.3 comma 0 here. And I'm just going to double check to make sure they're about symmetric. If I draw a vertical line or the axis of symmetry, they do seem to be about equidistant from the axis of symmetry. So we are looking good. It looks like the points are correct. So we have the x-intercepts. we have the exact version of the x-intercept, and we also have the approximate versions of the x-intercept. One more step, we need to find the y-intercept. To find the y-intercept, you let x be equal to 0. So this one's fairly easy. We have y equals 0 squared minus 4 times 0 minus 7. So y equals negative 7, which means our y-intercept is the point 0, comma, negative 7, which is all the way down here, 0, comma, negative 7. But I could use the axis of symmetry again to find another point. This is 2 units away from the center, and so we have another one on the other side. Let's finish the sketch of our parabola. And so it looks like a U-shaped object. It goes forever to the left and forever to the right. So again, start by finding the vertex. After you find the vertex, find the x-intercept. The x-intercept in this case was quite difficult because the equation was not factorable. We had to use the quadratic equation to find our 2 x-intercepts, and then we finished it off by finding our y-intercept. Example 4, we'll start by finding the vertex again. Let's let x be equal to negative b divided by 2a. We're finding that vertex. In this case, we have b is 6, so it's negative 6 divided by 2 times 1, which gives us a negative 3. Substituting the negative 3 into the original equation, we have the following. Y equals negative 3 squared plus 6 times negative 3 plus 9. We'll simplify this. Negative 3 squared is a positive 9. 6 times negative 3 is negative 18 plus 9. So in this case, we have the y is equal to 0. Now we have the x coordinate is negative 3 and the y coordinate is 0. So what's our vertex? Our vertex is the point negative 3, comma 0. So let's graph that. It's the point negative 3, comma 0. And this is the point negative 3, comma 0. Now let's find the x-intercept. To find the x-intercept, you let y be equal to 0 in the original equation. We'll let y be equal to 0. So 0 equals x squared plus 6x plus 9. And we're going to factor this if possible, and it is factorable. This factors as x plus 3 times x plus 3. This gives us x equals negative 3 or x equals negative 3, which means we have the same point. So we'll just write it once. We have the x-intercept is the single point negative 3, comma 0, which we have already plotted on the graph. And that makes sense. The vertex is also the x-intercept. Now we'll find the y-intercept. To do this, you'll let x be equal to 0. Let's let x be equal to 0. And we'll plug in 0 into the original equation. So y equals 0 squared plus 6 times 0 plus 9. And that gives us y equals 9, which means the y-intercept is a point 0, comma 9. We'll plot that on the graph, 0, comma 9. And that is right here, the point 0, comma 9. After that, we'll draw our axis of symmetry, which runs down the middle of our parabola. And we can find another point. This is another point that is symmetric across the axis of symmetry. So we'll sketch our parabola, a U shape that runs through these points. So we're only able to get 3 good points, but that's the best we can do. So this is our parabola with a vertex at the point -3, 0, an x-intercept at -3, 0, a y-intercept at the point 0, 9. Let's look at example 5 now. We'll start by finding the vertex. To find the vertex, again, you let x be equal to -b divided by 2a. And so in this case, we have a -2 divided by a 2 times 1. The a is a 1, and the b is that -2. So let's simplify this. This simplifies to a +2 divided by 2, so that's a 1. That means the vertex is the point 1, something. So we'll put 1, and we'll have to figure out what the y coordinate is. So let's substitute the 1 into the x's. And so we get y equals 1 squared, which is 1. -2 times 1 is -2 plus 2. And so that gives us y equals 1. That means my vertex is the point 1, 1. Let's graph that vertex, 1, 1. The next step is to find that x-intercept. You're going to let y be equal to 0. And so 0 equals x squared minus 2x plus 2. Now, if you want to do this, you could either use the quadratic formula or complete the square. It is not factorable. Unfortunately, it's not factorable. So I'm going to choose to complete the square because in the previous example we did the quadratic formula. So let's use a different technique. To do completing the square, I want to rewrite this. So let's subtract the 2 to both sides. So you can switch it around. It is x squared minus 2x equals -2. Now I could add something to both sides to complete the square. To complete the square, you have to add b divided by 2 squared to both sides. Now, don't get confused with the previous formula. The formula before is x equals -b over 2a. That's to find the vertex. To complete the square, we use a b divided by 2 squared. So slightly different. Our case has a -2 here for the b. -2 divided by 2 squared, you get a +1. So on the left we have a +1, and of course we have to add that same number on the right. So this factors as x minus 1 squared. Again, that trick with that completing the square is to take that b divided by 2, you get it down here. And if you're not sure how to do that, look at the videos for completing the square. This gives us a -1. How do you solve for this? Well, you'll take the square root of both sides. Don't forget the plus or minus. So this simplifies now to x minus 1 equals plus or minus, what's the square root of -1? That's going to be I. So that's a problem. That means if I were to solve for x, let's add 1 to both sides. You get x equals 1 plus or minus I. This is an imaginary result. You can't graph an imaginary number onto the Cartesian plane. So that means there is no x-intercept. There's no x-intercept. So there is no x-intercept. Let's see if there's a y-intercept. So we have the vertex already graphed. Let's find the y-intercept. To find the y-intercept, you're going to let x be equal to 0, and we'll replace all of the x's in the original equation with a 0. And this is fairly easy to do. We get y equals 2, which means the y-intercept is the point 0, 2. Let's go to our graph and we'll plot the point 0, 2. This is the point 0, 2. And now we have to do the axis of symmetry, which runs through the vertex. The vertex is the point 1, 1. And I'm able to find another point here through symmetry. It is exactly the same distance. And so we have our parabola. We're able to only use 3 points here, but we still have that general shape for that parabola. Now let's look at this graph one more time. And why did we have no x-intercepts? Well, you can see that the vertex is above the x-axis, right? The vertex is above the x-axis, so it makes sense. It makes sense that the graph does not have an x-intercept because the vertex is above the x-axis. Let's look at our last example now. In example 6, we have a negative in front of our graph. Let's see what happens when there's a negative in front of our graph. We'll start with the vertex again. We'll find the vertex with the formula x equals negative b divided by 2a. This is going to be a negative 4 on the top divided by 2 times a is negative 1. So this simplifies to a positive 2 when you do the math. So that means the vertex is the point 2, something. We'll substitute into the original equation with x being equal to 2. Now be careful when you do the substitution. You want to make sure you use parentheses. Because in the first case, negative 2 squared is actually negative 4 because the parentheses only includes 2. So this is negative 4 plus 8. 4 times 2 is 8. And then we have a plus 12 here. So we can simplify this as y equals negative 4 plus 8 is a positive 4. And then if we add 12 to that, that gives me y equals 16. So the vertex is the point 2, 16. And this is going to be a little bit off our graph. So we'll estimate this is 2, 10, 11, 12, 13, 14, 15, 16. So let's say the graph goes to here. Let's suppose our graph goes to here, and this is the point 2, 16. And so we have the vertex. What's next? The x-intercept. Let's let y be equal to 0. And so we have 0 equals a negative x squared plus a 4x plus a 12. And I don't like that negative in the front, so what you could do is you could divide everything by negative 1. This simplifies our equation. Let's rewrite it. This simplifies as a 0 equals x squared minus 4x minus 12. Again, I don't want the leading coefficient to be a negative. It just makes it difficult to factor. But now I can factor this with the diamond technique, right? The leading coefficient has to be positive for the diamond technique to work. So this factors as x minus 6 times x plus 2. So that means we have two x-intercepts. We have x equals 6 or x equals negative 2. set each of these factors equal to 0. And so we get 6, 0 as one x-intercept, and the other one is negative 2, 0. So we'll put 6, 0 and negative 2, 0 as our x-intercepts. Now I want to double check, is that equidistant with the axis of symmetry? Yes, it is. So we know we're on the right path. So always double check to make sure it looks symmetric, and it does. Now let's find the y-intercept. To find the y-intercept, you're going to let x be equal to 0. Looking back at the original equation, let all of these here x values be equal to 0. So we y equals negative 0 squared plus 4 times 0 plus 12. So this is easy. It's just y equals 12. That means the y-intercept is the point 0, 12. Let's plot the y-intercept 0, 12. And again, it's off our chart, but we can estimate it to be at this point 0, 12. And using symmetry, we could draw another point that is equidistant here at the point 4, 12 on the other side. And now we can draw the parabola, and it's different than the other ones. What did that negative in front do to our graph? The negative forced this parabola to be upside down. So this is an upside down parabola. If you ever see a negative in front of the x squared term, it's going to force our graph to be upside down. It's a u that goes down. It's upside down.